In this section, we're going to talk about a new concept, something called a complex number. And so what a complex number is, just by definition, complex number. A complex number in general, well, the most basic complex number is the number I. And I is equal to the square root of -1. So this is a complex number, I. And in general, we can have complex numbers of this form, a plus bi. And these a's and b's are just numbers. So for example, maybe something like 3 plus 2i, and just 6i, or even just 7, because 7 can be written as 7 plus 0 times I. So all three of these things are complex numbers. So what a complex number basically is just you have two parts to it. You have something with just a number, and something with just a number plus this this number I, which we're defining to be the square root of -1. So if you remember in previous sections, we were never able to have a negative inside of the square root. And the way we take care of it is well, now we allow it. And so here's just a quick example. Say if we want to do something like this, the square root of -24. Before we would say, if we came up with this in one of our answers, it's just, no solution or undefined because we have a negative inside of our square root. But now how we handle this is, in this problem in particular, so let's simplify this one. So we remember there's properties of square roots. We can break up, so this inside piece, we can just rewrite that, kind of like -1 times 24. That's the same thing as -24. And with square root signs, if things are multiplying, you can break them up with different square roots, meaning that we have -1 times 24, so we can do the square root of -1 times the square root of 24. Okay? A second ago, we saw that just this, I is the square root of -1, so we just replace this with I. So this is just the same thing as I times the square root of 24. And then, we could simplify the square root of 24. We do that tree thing. So 24, we can write that as 6 times 4. And we can write this 4 as 2 times 2. So we can simplify the square root of 24. We can bring out one of these 2's, 2i. And on the inside, we still have 6. And so this is how we can handle now something like the square root of a negative number. All we just do is pretty much, if you see we skip, say, from this line to this line, if we see a minus sign on the inside, all we just do is write an I on the outside, and then just write the number on the inside without the minus sign. So these are all equals. This equals that equals that. If we just skip from here to here, you see when we have a minus sign on the inside, all we're doing is, again, get rid of the minus sign. So now there's only a 24 in here, not a negative 24. And when we get rid of the minus sign on the inside, all we have to do is just write the letter I on the outside. So this in general, that's what a complex number is. It's just something of this form, like these three things here. And let's do a couple of examples of how we can add and subtract complex numbers. So add, subtract. So when we're adding and subtracting, let's say this first example here, let's just do, not A. How about 2 plus 2i minus 7 minus 6i? So when we're adding and subtracting these complex numbers, we can just pretend like this I isn't anything special. It's just like an X. So we're just going to combine all like terms. So if we're going to subtract these two numbers, we can just first distribute this minus sign, 2 plus 2i, then minus 7 minus a minus 6i. This minus sign goes here, and the minus sign goes here. So the minus 7, and then a minus 6i, so plus 6i. And now let's combine all the like terms. We have a 2 minus a 7, that's a minus 5. 2i plus a 6i, that's an 8i. So you see, all we just did here is we just pretended that this I was just a variable. So it could have been an X, it could have been a Y, it didn't really matter. That doesn't change how the answer goes when we're adding and subtracting these complex numbers. And just to complete this example, doing one with addition, so the same thing will happen. Say if we do 7 plus 16i plus, how about 32 minus I. So there's a plus sign here, so we can just get rid of these parentheses. So we have 7 plus 16i. And the reason why we can get rid of those parentheses, we can think about that as there's just a positive 1 in the front. So we're doing 1 times 32, 1 times minus I. That's just plus 32 minus I. Okay, so here we have a 7 plus a 32. That's a 39. And then we have a 16i minus an I, so plus 15i. So again, nothing different as if we could just pretend this was an X, and we would just combine those numbers just like we have been doing. Now let's talk about multiplying and dividing complex numbers. So multiplication and division. Okay, so let's start with again, let's just do two quick examples for each of these. Say if we have the two complex numbers, 2 minus 6i, and now let's multiply it with 3 plus 2i. Okay, in the beginning we can again just pretend like these are variables, like this I doesn't mean anything special. So just like before, we multiply things like this together, we FOIL. 2 goes to the 3, 2 is going to go to the 2, minus 6 to the 3, minus 6 to the 2. So we're going to get 2 times 3, which is 6. 2 times 2, so 4i. Minus 6 times 3, so minus 18i. Minus 6 times this 2, so minus 12. And again, so I times I, so I squared. Just like if this was a variable, like a variable x, it didn't mean anything. So now let's combine the like terms here. We have 6. Here's a 4i and an minus 18i, so we get minus 14i, minus 12i squared. But now we're going to do one more step of simplification. So we said on the previous page, I was square root of minus 1. So if we square I, well, that means we're going to square the other side. We're going to take that and square it. And if we remember, whenever you square a square root, you just get rid of the square root sign. So this is going to be minus 1. So this right here, this little bit, this is going to tell us that I squared is the same thing as minus 1. Okay, so right here we see an I squared. So we can rewrite this. This is going to be 6 minus 14i minus 12, and this I squared is a minus 1. Okay, so now let's keep simplifying. 6 minus 14i minus 12 minus 1, so plus 12. And here we're going to have 6 plus 12, which is 18. So 18 minus 14i. Yeah, so this is how we would just multiply two complex numbers together. And now let's do one with division. So about 7 plus I over, example, let's do 2 minus 3i. So when we're dividing two complex numbers, we have to do something called multiplying the top and the bottom by the conjugate of the bottom. So whenever we see a problem like this, the first thing we do is we look at the bottom, and we want to multiply the top and the bottom by the conjugate of it. What the conjugate means is you take the same exact number, this 2 minus 3i, and just replace whatever that sign is with the opposite one. So for this example, instead of multiplying the top and the bottom by 2 minus 3i, we're going to multiply the top and the bottom by 2 plus 3i. 2 plus 3i, 2 plus 3i. Again, so if this was a plus sign, we'll do one in the next example, if this was a plus sign. But if that's a plus sign, then we would put minus signs over here. But basically, we just take the bottom number, switch the sign, and multiply the top and the bottom by it. Okay, so now we're just multiplying fractions. So we multiply the tops, multiply the bottoms. So the top of this fraction is going to be 7 plus I, 2 plus 3i. The bottom of this fraction is going to be 2 minus 3i, 2 plus 3i. And now we just continue like we did before. We have to multiply these two top ones together and multiply these two bottom ones together. So on the top, we're going to get 7 times 2, which is 14. 7 times 3i, which is 21i. I times 2, which is 2i. I times 3i, which is 3i squared. On the bottom, we're going to get 2 times 2, which is 4. 2 times 3i, which is 6i. Minus 3i times 2, which is minus 6i. Minus 3i is going to be minus 9i squared. Okay, now let's do the simplification. So right here we have a 14 and a 3i squared. Remember, this I squared meant minus 1. So this is really, instead of a 3, this is a minus 3. So we have 14 minus 3, which is 11. And 21i plus 2i, which is 23i. Now on the bottom, these i's cancel. 6i minus 6i. And here we have a minus 9i squared. But remember that I squared is minus 1. So instead of this being minus 9 I squared, this is minus 9 times minus 1. And minus 9 times minus 1 is positive 9. So this is really 4 plus 9, which is 13. And so this would be the answer. And this quick last example. Let's do one like where this was a plus sign on the bottom. So and the top sign doesn't matter. This could be a minus or a plus. All that matters for division is the bottom sign. So let's say if we had 16 plus 2i over 3 plus 17i. The first step that we would do for this one is multiply the top and bottom by 3 minus 17i, 3 minus 17i. And then, we would multiply the tops together. So let's just do this one last step. 16 plus 2i, 3 minus 17i. And on the bottom, we'd have 3 plus 17i, 3 minus 17i. And then just like before, we'd FOIL out and simplify everything. So we don't need to continue from there. Just the main idea is when you're dividing two complex numbers, you see here when we have the positive sign on the bottom, we just take that same number, but then make it a minus sign. And then up here, when we have the minus sign on the bottom, again, we take that same bottom number and then put a plus sign. So as far as multiplying and division goes for complex numbers, this would be it. So the last thing from this section is just going to be solving equations for x, but now we might have answers that are complex numbers, whereas before we would just say the answer is no solution. So a simple example, say if we have x squared plus 25 is equal to 0. So before, let's do 2 steps first. We can subtract this 25 over, so we get x squared is equal to minus 25. And we know whenever we have x squared is equal to a number, that just means x is equal to plus minus the square root of that number. All we do is take the square root of both sides and we have to put a plus minus sign in the front. So we have x is plus minus square root of minus 25. Now, as before, we would say there's no solution here because we weren't able to take a square root of a negative number. But we just saw a second ago that now we're able to, we call it I. So we can simplify this. This is going to be x equals plus minus. And if you remember the first example we did, whenever there's a minus in a square root, we can get rid of that minus, write the letter I, and then just write the number without the minus sign on the inside. So again, we can just get rid of this minus sign, put an I on the outside, and now just have that number on the inside. And then we know that square root of 25 is 5, so this is going to be x is equal to plus minus I times 5. Okay, let's do one last example together. So this one, let's have x squared plus 2x plus 1. Sorry, let's make this a 2 in the front. Is equal to 0. So for this example, we could try factoring, but we're going to see that it's not going to be possible. If we did the AC method, you remember how you say, let's do that to show why it's not possible. So say the only way to factor this one is the AC method. And we know that because there's a number in front of the x squared. Whenever there's a number in front of the x squared, we have to use the AC method. So the AC method says you take your A and your C and you multiply them together. So our A is 2, our C is 1. 2 times 1, that equals 2. And now we need to find things that multiply up to 2, but then add up to the middle one. Our only options for things that multiply up to 2 are going to be 1 and 2 and minus 1, minus 2. These are the only things that we can find that multiply up to 2. But in either case, if we add these two together, we get 3. That's not the middle one. If we add these together, we get minus 3. Again, that's not the middle one. So this one's not going to be able to be factored. So we have to use the quadratic formula. So remember the x equals negative b plus minus the square root b squared minus 4ac all over 2 times a. So if we fill in the formula with this a, b, and c, we get x is equal to negative b, so negative 2, plus minus the square root b squared, so 4, minus 4 times a is 2, c is 1, all over 2 times a, so all over 4. So we get x is equal to minus 2 plus minus. So here we have 4 times 2, which is 8. So 4 minus 8, which is minus 4. All over 4. We have minus 2 plus minus. So remember here, we have a minus on the inside. We can just take that on the outside as an I and just rewrite that. But again, square root of 4, that's just 2. So we're going to get x is equal to minus 2 plus minus I times 2 all over 4. So we're going to have 2 answers. Let's write them both out. We're going to have minus 2 plus 2i over 4. And we're going to have, minus 2 minus 2i over 4. So these are going to be both of our answers for this one. So again, all we did here is so we got to this step, then we say minus 2 plus 2i right here, minus 2 minus 2i, and then all that divided by 4. So for this example, quadratic formula, we see that we get a negative on the inside, so that means there's a complex number, and these end up being the 2 solutions for this problem.